Hi guys, welcome back to my channel. So today, let us know the 5 theorems in circle which you learn in 10th standard. So first let us know the basics in circles, okay? I think this is a circle. Now, I'll draw a diameter where O is the center. This is the diameter. Now, the two parts when a diameter is drawn, it is known as semicircle. Okay? When there is a diameter, this and this will be the semicircles of the circle. Now, I'll draw a chord. Now, AB chord is drawn in this circle. Now, this is smaller compared to this whole part, right? Now, this part will be called as the minor segment. Both will be segments, but this, because it is small, it is the minor segment, while this, which is the larger part of the circle, will be the major segment. Okay, that is the basic. Now, one more thing, because this will come in one of the theorem. Now, this is a four-sided, right? This is the four-sided figure. AB is a four-sided figure. What is a four-sided figure called as? It's a quadrilateral. We don't know what type of a quadrilateral it is, but this is a quadrilateral normally when we learn it. But if the four vertices of the quadrilateral are on the circumference of the circle, then it is called a cyclic quadrilateral. Now, I draw another type of a quadrilateral. Now, let me take this as P, Q, R, S. Is this a cyclic quadrilateral? No. Why? Because the four vertices are not in the circumference but inside the circle. So it is not a cyclic quadrilateral. Okay, now the basics are done. Let us start with the theorems. So, the first theorem goes like this. Now what is this? This is a circle, right? Now let me take a chord again, and let me take a center O, and let me take this as AB chord, and I'll join this with the center. This becomes a triangle, right? Again I'll take another triangle over here. Now what is this angle? It is the angle at the center, and this will be the angle at the circumference. Now, the first theorem states that the angle at the center is twice, that is, it is double the angle at the circumference. If this is C, now angle AOB is twice the angle ACB. Another way to tell it, ACB is half of AOB. That is the first theorem. Now let me go to the second theorem. Now, the second theorem, this is a circle, think that it is a circle, okay. Now, I'll take a chord, AB. I'll take another chord. Now, all are chords only in this. Why? Because it is touching 2 points in the circumference. Now, one question, which is the longest chord? Diameter, yes. What is ACB? It's a triangle. And what is ADB? It's also a triangle. Now, the second theorem states that the angles which lie on the same chord, these two angles lie on the same chord, and they are in the same segment. Now, that is itself the second theorem. The angles in the same segment which lie on the same chord are equal. For example, if this angle C, if I take it as 60 degree, then angle D also will be 60 degree. In a few sums you will get, for example, you get only angle ACB, you don't get angle ADB, you have to find it. You can use this theorem to find it because this is equal to this, only when they lie on the same column. Okay, that is the second theorem. Now let's go to the third theorem. Now the third theorem, now this is the center, which is O. Now if I take a line, a straight line which passes through the center, it becomes a diameter. I will take one triangle. Now here starts the third theorem. The third theorem states that an angle at the circumference which is in a semicircle. Why is it a semicircle? Because there is a diameter and the two parts will be the semicircle. The angle in a semicircle at the circumference will be 90 degrees. It may be any number of triangles, it will still remain as 90 degree itself. That is the third theorem. Now we'll go to the fourth theorem. Now the fourth theorem, same, I'll take a circle over here. Then now I will take a four-sided figure. What is a four-sided figure called? A quadrilateral. Okay. Now what type of a quadrilateral this is? It is a cyclic quadrilateral. Why? Because the four vertices are on the circumference. Now I'll name it as A, B, C, D. Now the fourth theorem states that the sum of opposite angles, for example, let me take angle A and angle C. These two are the opposite angles, which is why I took A and C. So the sum of the opposite angles, that means angle A plus angle C, will be supplementary. Supplementary means 180. The sum of the opposite angles of a cyclic quadrilateral is supplementary, that is 180 degrees. That is the fourth theorem. If the same thing, I'll take a circle here and this is the center. I'll take a quadrilateral like this. Here the opposite angles won't be supplementary, the sum won't be supplementary. Why? Because it is not a cyclic quadrilateral. Only over here, only when the quadrilateral is a cyclic quadrilateral, then only it will be supplementary. Understood? So the fifth theorem and the last theorem for today. Now there is a circle and I'll again take a cyclic quadrilateral. But the fourth side I'll extend it. Now if I extend this side, what will this angle be? Because it is outside the quadrilateral, it will be the exterior angle. So I'll again name it A, B, C, D and E. So ABCD is a cyclic quadrilateral. Now the fifth theorem is that the exterior angle of what? Of a cyclic quadrilateral is equal to the interior opposite angle. It may be any side. If I extend this side, here the exterior angle will be formed. If I extend this side, here the exterior angle will be formed. So it can be any side. It will be equal to the opposite interior angle of the cyclic quadrilateral. That is the fifth theorem and the last theorem. If successfully completed it, if you have any doubts, you can definitely ask me in the comment section below.
I hope you understood it. Thank you so much for watching. Make sure you like, share and subscribe. Thank you.